The series below converges to, and we have 1 over x, 1 minus x over 2, x cubed over 24, okay. So this looks like a Taylor series. And there is only a handful of Taylor series that you really need to know. So the first one would be, let's say, cosine of x, which is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial. And one of the ways you can kind of remember this is when you look at cosine of x, so it looks kind of like this. So cosine of 0 is going to be 1, so it makes sense that 1 will be the first term. And every thing is squared, so, or, of an even to an even power. So what that means is that it's an even function. By even function, I mean that the positive values mirror the negative values. So if it was like a piece of paper, you could fold it over onto itself and it would match up. And that's what an even function means. And since cosine of x kind of looks like this, then it goes on like such. You can fold cosine of x over on itself along the y-axis, and it would match up. The negative values are the same as the positive values. And when you see all these squares in here, x to the 4th is squared, it's just x squared squared. And x to the 6th is a square, it's just x squared cubed, etc., etc. Then you're going to get the negative and positive values the same. And that's one of the ways you can remember it. So then you have sine of x equals x, and then it follows the same pattern, but it uses the odd values. So 5 factorial plus, minus x to the 7th to 7 factorial plus x to the 9th over 9 factorial. And the way you remember this one, at least the way I remember it, is the first term. One of the things you'll learn is the small angle approximation. It's a big deal in physics. It's very useful in physics. So for a small angle, sine of theta is kind of sort of almost theta. And where that comes from, it's first order linear approximation. So the sine kind of looks like this. And you're like, well, when you get close to 0, it's almost kind of like a straight line. And that's where it comes from. You start with the x, and then you follow the same pattern that you did with cosine, where you go up by powers of 2 each time. And then you remember to divide by the same power that you divide by the number that's the same as the power. So 3, 3, 5, 5, 7, 7. And then you have e to the x, which is sine of x and cosine of x basically just add together, but it's all positive values. So you start with, I guess, the smallest one, which would be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial, and so forth. All positive values. And these are only the 3 that you really kind of sort of need to know. Yeah, there's some others that might be useful, but these are the big ones. And you should kind of have them memorized. And that's how I memorize them. So we look at this, and it's like, all right, the first term is 1 over x. So it's probably going to be something divided by x. So if we multiply all of these by x, then what we would get would be, multiply by x, we get 1 minus x squared over 2 plus x to the 4th over 24 minus x to the 6th over 720. Okay, and then it goes on for such. And it looks like there's a general term there, but I'm not going to think that deeply about this. So this, we can see, all right, that looks like cosine of x. So it looks like this is going to be cosine of x over x. Your first thought is you look at this like, all right, 1 x to the first. So you see x to the first, x cubed, x fifth, and you immediately think sine of x because of the odd powers, but really it's the cosine value divided by x. Another thing to look at here is, let's see here, 2 is 2 factorial. This is 2 times 3 times 4, because that's 6 times 4, which is 24. And I kind of assume that's 2 times 3 times 4 times 5 times 6, so 30. Yeah, that seems right. So it follows the same pattern. And so we look at what we got here, and it's going to be this value right here. And for something like this, you'd kind of be tempted to look at the answers and then try and be like, all right, which of these answers make sense? But it could take a while to go through these. The way to look at this is, this is a tough one to do because there's no real good path of like, all right, this is where you start with point A, you go to point B, and then your journey's done. A lot of this is kind of like look at it and intuition guess. And sometimes that works really quick. Sometimes that works really slow. I guess the good point about this is you only need like 60-70% on the test to get a 5. So you don't have to get them all correct. And it's easy to know when you have the right answer with this one, but it's not necessarily quick. And since there's such a strong time element for AP exams, it becomes frustrating. So for this one, you look at it, you know the answer. You have to have memorized cosine of x, the Taylor expansion, sine of x, Taylor expansion, and you can derive it, but you won't have time. So I recommend knowing it because it's reasonably easy to memorize one because it follows a reasonable pattern. If you know one, you can kind of figure out the other one. And then if you know cosine of x and sine of x, then it's pretty easy to know e to the x as well. So get those in your head, stick them in there, move on with life. So that's the kind of problem you might see for a Taylor expansion.